Alright, so here we are in our third section for the angle addition postulate, and here we're going to add in some algebra. So we look at this very first example, and notice this. It says that line segment KA, and that should actually even be ray KA, is perpendicular to ray AG. So what is this actually telling us? We'll think back to our notes last time. Whenever two lines are perpendicular, what kind of angle do they form? And of course they form a right angle or a 90-degree angle. So when we see that two lines are perpendicular, we know that they are complementary. And I'll just abbreviate that as comp. Okay, so we have this complementary, or these complementary angles, and we see the value of, we're looking for the value of x and the value of angle JAG. So ultimately, we want to know how large is that angle, and we're given that KAJ is 2x plus 4, and we're given that JAG is going to be 6x minus 2. Now, once again, what does complementary mean? It means that these two angles, these two pieces of angles, have to add up to be 90 degrees. And so we will write 2x plus 4 plus 6x minus 2 is equal to 90 degrees. Now you'll notice something. I actually made a mistake here. What I should have written first was angle KAJ plus angle JAG is equal to 90 degrees. And I promise if you get in the habit of doing that first, you'll be able to do the algebra. You'll always be able to set it up correctly. So when I look at this equation right here, I notice it's a little bit longer and more complicated than the problems we were solving last time. And what we want to do is start by combining our like terms. So I see a 2x here, and ask yourself, what is the other thing that will combine with 2x? And it will be that 6x. So we know that 2x plus 6x would be, good, 8x. And now we have plus 4 minus 2. And guys, this sign right here is so important, this minus 2. And ask yourself, what is 4 minus 2? Well, of course, that is plus 2, is equal to 90 degrees. Now from here we're going to solve for x, and we've been using the Pemdas tool, and here's where I'm just going to start to talk through the Pemdas tool. So what do we always get rid of first? The multiplication or the addition. And of course we get rid of the addition by subtracting 2 from both sides. You can even draw your line through the equal sign if that helps you out. So we have a 0 pair there, it's gone. And we have 8x equals 90 minus 2, which would be 88. Now how are we going to get rid of that 8? We know it's being multiplied by the x, and what is the opposite of multiplication? We divide both sides by 8. And 88 divided by 8, you should know this off the top of your head, is 11. Now notice, this is where geometry is going to start to get a little bit more rigorous. This says find the value of x, check, but it also says find the value of angle JAG. So how do we do that? Well, I know that angle JAG as an expression is going to be 6x minus 2, and I know that x is 11, so all we have to do is take this x and plug it in right there. And the best way to do that is to always first replace the x with a set of parentheses. So instead of writing 6x minus 2, I wrote 6 parentheses minus 2, and there I'll put in the 11. Now what is 6 times 11? That is 66 minus 2. And what is 66 minus 2? That is 64. And so we can say that angle JAG is equal to 64 degrees. Always pay attention. What is the problem asking you? Is it asking you for x, or is it asking you for the angle? Alright, I would pause this, I would finish taking notes. We're going to move on to our second example. Alright, now welcome to the hardest problem that we've gone on or over so far this year. So this says draw angle ABC Let me go ahead and underline that. Draw angle ABC, where ray BD lies somewhere in between, and then it wants you to find the measure of angle ABD. Now here it gives us the information of the angles, but more importantly, it tells us the angle ABC, the whole angle that we want to draw, is 84 degrees. Now why is it being 84 degrees that's so important? 84 degrees is less than 90 degrees. That means we're drawing an acute angle. So if you'll remember, here is an obtuse angle, here is a right angle, and here is an acute angle. So this will kind of help us draw our picture correctly. So I'm going to draw myself an acute angle, and I'm going to know that no matter what, that whole thing is going to be 84 degrees. Now notice it says angle ABC. Remember, you could start with angle A right here. B always has to be in the middle because it's the middle letter, and then of course that would be angle C. And from here, this is the part that I think might confuse all the most. It says ray BD lies somewhere in between. Does this mean that it's exactly in the middle? No, it just means that it's going to be kind of offset, something like that. We'll put the letter D, and there's our ray BD. Now, it says find the measure of angle ABD when ABD is 5.3x minus 6. And ask yourself, is ABD the top part of the angle, or is it the bottom part of the angle? And here, of course, A to B to D will be the top. So I can say, hey, that is going to be 5.3x minus 6 degrees right there. Now, what about angle DBC? Well, it tells us that that will be 2x plus 24 degrees right there. And now we've successfully drawn this angle. And think about it. Here, we know the part, and here, we know the whole. And for our angle addition postulate, or even our segment addition postulate, it's always going to be part plus part equals whole. Now, I want to go ahead and write angle ABD plus angle DBC is equal to, and here we actually can go ahead and write angle ABC, which is the whole thing. Now let's plug in the things we know. We know that angle ABD is this 5.3x, that's a weird 3, minus 6 plus, now what is angle DBC? 2x plus 24, and that will of course be equal to 84. Now, much like our last problem, we want to combine our like terms. So I see the 5.3x plus 2, and the cool thing about adding a decimal and a whole number, when there's no decimal, I can just add this 2 to the 5, and 5 plus 2 would give us 7.3x. Now what about this negative 6? And guys, remember, it is so important that you keep account of that negative or the sign in front of the number. It's a negative 6 plus 24. Or aka, what's 24 take away 6? And that would be 18 is equal to 84. Now from here, we know that we always get rid of our addition first. So minus 18, and we'll have 7.3x equals 84. Now look, I could do 84 minus 18 in my head, but even I'm prone to making mistakes. So use a calculator. Google Desmos Scientific Calculator, or I should have a calculator linked up in the description. We can do 84 minus 18, which will give us 66. So, do y'all see how I wrote 84 right here? That was a mistake on my part, and I should have written 84 minus 18, which, like I just told y'all, is going to be 66. Now from here, we divide both sides by 7.3, divide by 7.3. I'll go back to the calculator. And 66 divided by 7.3 will give us 9.04. And so we know that x is equal to 9.04. Now what did I ask y'all to do in the last one? I asked you to always read what is the question asking for. And here, This one is asking us for angle ABD. It's not asking us for x. If you choose 9.04 as your answer, that is incorrect. So we look at ABD, and we know it is the top angle, so I can write angle ABD equals 5.3 parentheses minus 6. Remember, when replacing that x with a number, always change it to a parentheses first. And I'll plug in 9.04. Here, you'll definitely need your calculator. So we have 5.3 times 9.04, which will give us 47.91 minus 6, which will give us 41.91. And of course, this was angle ABD. Angle ABD will be 41.91 degrees. Alright, hey look, I hope this helps out. I know this is going to be a difficult section. Just use your angle addition postulate. The part plus the part is equal to the whole. Or if it's one of the segment addition problems, the part plus the part equals the whole. And once again, always ask yourself, is it asking me to find x, or is it asking me to find an angle or a line segment, which means you need to take that x value and plug it back in. Good luck, guys. I'll see you all in our next section.